So a field is bounded on one side by a river. The field is enclosed on three sides by a fence, right? So to create a rectangular enclosure, the total length of the fence is used is 200 meters, okay? Use a quadratic model to determine the dimensions of the enclosure. Okay, so when you do these, I find when I do these, like the key to this is like drawing your picture, right? And so like if I've got this like river, right? And on the river, we've got like a field that's like attached to it basically, right? So you've got this instance where the river is acting as one of the side legs, right? And I think we've done a couple questions where like you maximize the area and it turned out to be a square, right? And these questions, like it's no different the way they're going to set this up, except for the fact that like you have more fencing or whatever they're using available to you, because you don't have to use it on the side, right?
Yeah.
Okay, so that's that so far. So there's two things. Anytime you're dealing with this, you've got kind of bounded by a river, you have some information available to you, right? And there's another key part to this question that I see here, right? What ultimately what it's asking you for.
To make it so it has the maximum area.
Yeah, so the maximum prompts me to talk about what?
A square.
Yeah, or also if I'm gonna factor or if I'm gonna complete the square.
Okay.
Right. So which one am I gonna do? If it's asking about a maximum, maximums come from what? What type of equation? So you got like standard.
Maximum comes from vertex.
Right. So like I'm gonna write
complete the square.
You gotta complete the square to get the vertex form.
Yeah.
Right. So do you want to try? How about I'll set it up for you.
Okay.
And then from there you can kind of.
I can just draw along.
Yeah. So.
Okay, so.
Okay, good. So you wrote down, what's good is you wrote down that there's 200 meters of fencing available, right?
Mm-hmm.
So what does that represent?
I have no idea.
Okay, so here's the two things, right? And these questions, anytime you see anything like this, it doesn't matter if it's like a farmer wants to create pens for chickens or something, like there's all sorts of different styles of questions, right? But ultimately, if you see maximum area, one of your equations better have something to do with the area. So I know the area of a rectangle or a square is length times width, right?
Mm-hmm.
So that's that one. Now the other one is it tells me information about the perimeter. Yeah, right. So if I can I have 200 meters available to me, right? And so what's the perimeter of this shape? Like if I were to go all the way around here, I don't need to count this side, right? I don't need to count the side along the bottom, right? So I go like a length plus a width plus a length. So it would condense to 2 lengths plus a width, right?
Okay.
So these are your two equations for these style questions, right? Always. And then the final step here is just to plug in the 200 for the perimeter, right? So one equation is going to be 200 is equal to 2L plus W. Okay? You okay with that so far?
Yeah.
And then you're gonna so you can plug the 200 into yours for the perimeter. So we'll just replace P. So it's 200 equals 2L plus W. Now, I know on the other side, why don't you write down area equals length times width? Like on the same line as perimeter, do area equals length times width. Okay. Now, if I'm ultimately trying to figure out what the maximum area is going to be, right? I can do some, like, not trickery, but like I can isolate from one of these variables. Right? In this case, I'm gonna isolate for W
Okay.
because it's already by itself, right? So it's easy. So all I have to do is move the 2L to the other side. So I know, based on the information that they've given me in the question, and by deducing the fact that perimeter is 2L plus W, that W is going to be equal to 200 minus 2L,
Okay.
right? Once I know that, I can take it and plug it into there,
Oh yeah.
right? I can replace the W in the area equals 9 times width with what I just solved for from the perimeter, right? So now I'm going to get, and this is kind of like A max, like that's ultimately what I'm trying to solve for, right? Is going to be equal to the length, right? And then that's multiplied against the width, right? But the width is now 200 minus 2L,
Okay.
right? So instead of using like a multiplication sign, I'm going to put brackets in, right?
Hold on, I did something. Okay, so let me just do it here. Yeah. Wait, so length times 2 minus 2.
Right? Now I would replace the multiplication sign, like what I did with the like put brackets around. So now this looks like something that you've seen before, right? In the sense that like when it, like, forget about the fact that this almost looks like factored form, right? I see two different things here. What I'm going to do, because we already talked about this, right, is if I'm asking about the maximum about something, or if it's maximum revenue, maximum area, whatever, right, you're going to complete the square, right? So factored form will tell me about like the roots, which in the context of this question, I don't know exactly what that means, right? Right? Like I wouldn't know, okay, L can equal 0 or L can equal 100. I don't know what that means, right? That's saying, like, it's not useful for the context of this, right? So factored form doesn't actually help you for this.
Yeah.
So now you're gonna expand, right? And then by doing that, you create a two binomial or a binomial, sorry. Right, so a two-term polynomial. So your A max now is going to be equal to 200L minus 2L squared. Right? And then I can rearrange that. Okay? That looks like something you've done before now, right?
Yeah.
So now all you're going to do now is complete the square from here down. Right? But what has to be true about, before you can complete the square, what has to be true about?
That has to be 1.
It has to be, the A value has to be 1, right? So I have to factor out this -2. And then once I do that, I'm going to be left with L squared minus 100 L, right?
Yeah.
And now I can complete the square on the inside. So I'm going to be left with -2, and then I'm going to go L squared minus 100L. And then I need to add and subtract that Z value, right? So we're just completing the square. So the Z value in this case is going to be equal to the B value divided by 2 squared. So -100 divided by 2 squared, right? Which is going to be -50 squared, which is going to be equal to 2,500. Right? Which means I'm going to add 2,500 and subtract 2,500. Okay. And then you can see that the first three terms,
Wait, what is 50 squared?
I think it's 2,500, I think, right? Is it?
I'll double
Five.
check.
5 and 5 should be 25.
That's true.
I think
Yes,
that's
2,500.
okay. Now the first three terms create a perfect square trinomial, right?
Yeah.
So you're left here with 2. I'm going to leave this first, and remember, sometimes I always like using the square brackets, right? Remember we did that because it's easier to see when I go to condense this down. I can see the perfect square trinomial, right? So that's going to condense down to L minus 50, right?
Squared minus 50.
Minus 2,500,
Oh, yeah. 25.
right? Because you added and subtracted 2,500, right?
Yes.
And now the next step here is to get rid of those square brackets. So I do that by anytime I get rid of brackets, you know that in order to get rid of them, you just expand across, right? So I'm gonna left with negative 2L minus 50 squared plus 5,000. Okay.
Plus, wouldn't it be plus 5,000?
Yeah.
Yeah.
Is that what you got?
Yeah.
That's what I got. So then the final step to this is going to be, okay, well, I always, and in the past when we've done this, I always ask you what the vertex is just for practice, right? So the vertex in this case is going to be
50 and 5,000.
50 and 5,000, right? And then it's at this point that you get to interpret this answer, right? So, the question can ask you two things, right? Sometimes it asks you, what's the maximum area? Right? And then, if that's the question, what's the maximum area that can be produced?
5,000.
Just 5,000, right?
Yeah.
So that's 5,000, right? Sometimes the questions can ask you two things. They could say, what are the dimensions that give me the maximum area, right?
Yeah.
Sometimes kids, like, they freak out when they see this, right? Give me right? Well, what are the dimensions then? Do you know?
Hold on. What? Pardon?
So sometimes you're going to be asked two things. You can be asked two things. I haven't finished reading the question that we've started, right? So in this one it says use quadratic model to determine the dimensions. See what it's asking?
Mm-hmm.
So this one actually didn't even ask what the maximum area was. It wanted to know what the dimensions were that produced the maximum area, right?
Mm-hmm.
Because maybe like the farmer doesn't actually care that, or whoever doesn't actually care about the fact that it's 5,000. He just wants to know how to break up the wood or whatever that he's bought to maximize the area, right? So so these are the two kinds of questions, right? So this one here, what would be one of the dimensions? You could read that one pretty easily, right?
50.
50.
Yeah.
Which one is that?
The X. Wait. The width? Length.
The length, right?
Length, yeah, because we isolated for length.
Right? So if you read the vertex, you're going to see that this is L and this is the area, right?
Yeah.
So I know that I know I get a maximum area when L equals 50. But there's two dimensions, right? So I got to figure out what W is.
Yeah.
Well, how would I do that?
Isolate for it, just like you've been doing.
I
wait.
think,
Put put the 50 in
yeah,
as L.
yeah. Into which one?
This one.
Didn't I already isolate somewhere for W?
Yeah. Wait. Did you?
Didn't we already
Oh yeah.
from the beginning? So if I plug in for L here,
Oh, yeah.
it's going to tell me what W is. So W is going to equal to 200 minus 2L, right? So the width that maximizes the area is going to be 200 minus 2 times 50. And I'm not sure, were these meters? Yeah,
I think so.
so these both have to be meters. Okay. They're your dimensions. So then you could write a final statement that says, therefore, is that good?